What is scalability? Scalability refers to the ability of a system to handle an increasing amount of work or growing demands by adding resources to the system. In software architecture, scalability often refers to how well a system can grow in terms of processing power, storage capacity, or throughput while maintaining acceptable performance level. We have two primary types of scalability that we will talk about. Let's try to talk about them, make this quite smaller. The first thing that we will talk about, which is the vertical scaling, also known as scaling up. Vertical scalability involves increasing the capacity of individual components within a system, typically by adding more powerful hardware resources, such as upgrading to a faster processor, adding more memory, or increasing storage capacity. While vertical scaling can provide immediate improvements in performance, it is limited by the maximum capacity of the hardware and can become um, pro- prohibitively expensive or impractical beyond a certain point. So let's imagine we have a client. Let's clear that. Let's imagine we have a client and we have a server. And if the client is sending too many requests to the server and the server reach its limits, the server needs to scale. So by vertical scaling, we will add more new resources. So basically, what we will do that we will just make this is and give it more RAM, more powerful tools, more CPU, and give it more resources so our server can handle more requests right now. But as we said before, we have some physical limits. We cannot add RAM forever. And also, we have another problem that we have what we call a single point of failure. So, if this server went down or failed, the full application it's basically gone. So, but this one, it's not impractical for highly available and distributed systems. So, what is the other solution for that? The other solution we can refers as horizontal scaling. Horizontal scalability, also known as scale out. Horizontal scalability involves adding more instances or nodes to a system to distribute the workload across multiple machines or resources. This approach allows the system to handle increased traffic or workload by adding more servers, virtual machines, or containers. Horizontal scaling is often more cost effective and flexible than vertical scaling and can provide better fault tolerance and resilience to failures. So, if we have our client here and our server, let's say that our server reach its limits, so we will add more servers to support our server. So we have S1, S2, and S3. And by this one, our client can send as many requests as it wants. And if the client sends too many requests, we can add more machines, so we can handle the loads no matter what. And also, if one of the servers, let's say S1, is done, uh, the other servers could handle the request of it. So we are highly available. We are all the time. We have a fault tolerance. We have better fault tolerance. We are more scalable. We are quite flexible, but also it comes with the potential of it's quite complicated to handle or to architect a highly distributed system or a scale out system. So, scalability is essential for ensuring that the systems can accommodate growth in data volumes, user traffic, or computational requirements, computational requirements, without experiencing degradation in performance or reliability. It is particularly crucial for web applications, cloud based services, and distributed systems that need to handle a varying levels of demand efficiency. So, let's talk about some key considerations for designing scalable systems in, um, in on a high level. The first thing that we will talk about, which is a decoupling. Here, designing a system with loosely coupled components that can be independently scaled. The other thing that I want to talk about, which is statelessness, minimizing reliance on server side state to enable easy horizontal scaling. Number three, load balancing, distributing incoming traffic or workload evenly across multiple servers or resources to prevent bottleneck and ensure optimal resource utilization. Number four, caching, using caching mechanisms to reduce the need for repeated computations and minimize database or network access. Number five, the database scaling. Employing techniques such as sharding, replication, or distributed databases to scale database systems horizontally. And lastly, we will not talk about the monitoring and auto-scaling. Implement monitoring tools and auto-scaling groups machines to dynamically adjust resource allocation based on real-time demand. So, in conclusion, scalability is a critical aspect of designing and managing modern software systems, allowing them to adapt and grow in response to changing requirements and user demands. So that's it for today's video, and see you in the future.